I thank you very much. Today, you're welcome again. Let's look at how we can derive the expression for the work done by an expanding gas. Let's consider an ideal gas. We are going to consider ideal gas. Now, when we say an ideal gas, this is the gas that actually obeys the gas laws. We are going to consider an ideal gas which is enclosed in a cylinder by a frictionless piston. The piston should be frictionless. There should not be any element of friction being involved. Then we are going to enclose this gas in a cylinder of cross-sectional area. Cross-sectional area A, and this gas expands by a distance change in what? In x, by actually putting a piston by a small distance change in x. As I can draw it, I can have a cylinder of that sort, and then I have this is a frictionless piston like that, and if I do this, I'll have that. This is the force acting this way is the force that is being exerted by the expanding gas on the piston, so I'll call it F, and it is the same force that pushes this side. It pushes the piston away due to expansion. It is PA, where P is the pressure of the expanding gas exerted by the expanding gas. So I'll have this distance becomes our change in x, and this is V1. The volume went towards V1, and when the piston expands, the volume becomes V2. This is cross-sectional area A, and this is exactly what happens. Initially, the volume V1, and then when it expands, the volume becomes V2. So therefore, say the force on the piston is given by F equal to PA. We know that from the definition of pressure, pressure is force per unit area. So when we make force the subject, which I'll have that force is equal to pressure times the cross-sectional area. So this is what we have. So the work done by the expanding gas shall have work done small change, because we have a small distance. So we shall have a small change in work would be force times the distance moved. The force exerted times the distance moved. But of course, our F force is pressure times the cross-sectional area. So this means we shall have that change in W is equal to F, which is PA, times change in X. I can change this and say this implies that I can have D change in work is equal to PA dx. I have changed from delta from a small change this to D, all the same. Small change in work, small change in x. So, but we also have to know that A dx is actually, this is area times the distance moved, is what we call volume, and this is going to be dV because we have a small change in distance, so this one becomes a change in volume. So therefore, shall have that dW becomes P times dV. So I am going to apply the integral on both sides of this equation. Therefore, we shall have that integral of dW would be equal to integral of P dV. But the volume, we are integrating. The volume runs from volume V1 to V2 in an expansion. So the volume changes from V1 to V2. So that means that at the end of it all, this is the sign of differentiation and the sign of integration, they cancel themselves. So we shall have their work done, therefore becomes P integral of the V1, V2. In this case, P, which is the pressure, becomes a constant in that case. So when I integrate this, I'll have work would be P. When I integrate the V, it's like there is a 1 here. This one becomes V, and then we shall have from V1 to V2. So this becomes work would be P, open a bracket, I will have V2, start by the upper limit, replace it here, minus V1. And this is the work done by an expanding gas. This is how we get it. Get a change in volume, you multiply with P. But of course, I can modify this, but then V2 minus V1 is what we call the V. Okay? Which is actually change in volume, this one here. So, or I can say change in V like that. Where, of course, where change in V is actually change in volume. Change in volume. So, therefore, work done would be equal to P change in V. So, generally, the work done, if we are to get the work done by an expanding gas, we need to know the pressure that has been exerted, that is being exerted by that gas on the cylinder, and we need to know the volume change from what value to what value. Just get the difference, we multiply them, that will give us the work done by an expanding gas. Thank you very much. Thanks for following.